Alright guys, so the next topic that we're going to be covering is interpreting slope. Okay, so interpreting slope and y-intercept. So it says here the table shows the height of a tree as a linear function of the number of years since it was planted. So we always have to remember, I'm going to repeat this 1,000 times until you guys memorize it. So X and Y, they went to the doctor, okay? DR, and they needed their ID. Remember, X is your domain, Y is your range, and X is your independent value, meaning it does that it doesn't need anything to continue. It just kind of goes. For example, like time passes, we can't stop time, we can't control time. Time just goes. Okay, so that's what it means, like independent. Dependent is what it depends on the independent variable. Okay, so here if we look, years after planting in T, and so we have 1 year, 2 year, 3 years, and 4 years. Okay, and then the height. So the height after we plant a certain kind of plant, it's in feet. So they have an H here for your height. So they don't have an X and a Y, they have a T and an H, but in the positions we know that T is our X value and H is our Y value. And so after 1 year, our plant is 4.5 feet. After 2 years, it is 7 feet. After 3 years, it's 9.5 feet. And after 4 years, it is 12 feet. So here it says, what is the independent value? So the independent value, just like I told you guys, is going to be our X value. So our independent value is the years after planting. So years. Okay. What is a dependent value? So the dependent value is going to be our Y values. In this case, our Y value is going to be H, which is feet. The height in feet. Then it says, what is the slope? So in order for us to find the slope here, we're going to go ahead and use our slope formula. Okay, just in case you don't remember, it's M equals, we subtract the Y values on top, because remember our Y values is our rise over our run. The X values on bottom. So then I'm going to go ahead and pick a point. This would be my X1, Y1. And this would be my X2, Y2. Okay, so then I'm going to go ahead and subtract 7 minus 4.5 on top. And on bottom, we're going to subtract 2 minus 1. And I'm going to go ahead and put this in my calculator. 7 minus 4.5, that gives me 2.5. And then 2 minus 1 gives me 1. So my slope here is going to be 2.5. Okay, so then here it says interpret the slope. So since this is 2.5 over 1, that means the rise is my feet. So it's going to be 2.5 feet every year. Okay, so interpret the slope every year. The plant grows 2.5 feet. Okay, then it says use the first point. What is a point slope equation? So I'm going to go ahead and write down the point slope equation. We have y minus y1 equals m times x minus x1. Okay. So then I'm going to use my first point, which is 4.5 and 1. So then instead of y1, I'm going to put, go ahead and copy it down. Y minus equals x minus. And so the y1 we said was 4.5. The slope m we know is 2.5. And then the x1, I already forgot the x1, it's 1. Okay, then it says, what is the equation of the line in slope intercept form? So I'm going to go ahead and distribute the 2.5 to each one first. And so we get y minus 4.5 equals 2.5x minus 2.5. Then we add the 4.5 to both sides. Plus 4.5 plus 4.5. And we get y equals 2.5x. Okay, because it canceled out here. And then 2.5 plus 4.5 is going to give us 2. Then it says, what is a y-intercept? Well, the y-intercept is 2. Okay. And it says interpret the y-intercept. So our y-intercept is always, remember, it's b where we begin. So the plant begins, or the plant starts at a height of 2. At a height of 2. Okay, and that's it for that problem. Okay, so here's another one. So it says, the graph shows the distance to the destination to be traveled by a car. From the time the driver leaves home to the time he reaches his destination, interpret the slope and the y-intercept. Write the equation of the line. So as we can see here, it crosses the y-axis at 200. So our y-intercept is 200. Our slope, let's go ahead and count our rise over run. So this is counting by 50s, okay? So it's going to be 50 here, plus another 50, that's 100. Another 50, that's 150, that's 200. So 200 down. And then this way it's counting by 1. So 1, 2, 3, 4, and 5. So the rise over run is 200 over 5. And when we divide those, that gives us 40. So the slope is 40. It says interpret the slope. So if I'm looking at the graph, whenever we are looking at the graph, we're going to go ahead and see our rise. Our rise here is 200, which when we reduced it in our slope, it'll be 40 over 1. Okay, so the rise is kilometers. It tells us here. So km. And then the run is hours. Okay. So just to read the the problem again, it says it's a destination to be traveled by car from the time the driver leaves home to the time he reaches his destination. Interpret the slope. So here for the slope, this means that they are traveling traveling 40 kilometers per hour. Then it says interpret the y-intercept. So the y-intercept is where we begin. So we started at, or this person started at 200 kilometers away from their destination. Then they want us to write the equation of the line. So our equation of the line is always in the form of y equals mx plus b. M being our slope, which we know is 40. And b is our y-intercept, which is 200. So 40x plus 200. And that's it. The next one, Audra is climbing a mountain at a constant rate. Her height at various times are given. So at 1:13 p.m., the height is 5,211. Okay. At 1:33 p.m., she climbs a little bit higher. It's 5,651. And then at 1:48 p.m., it is 5,981. So it says what is the rate at which she is climbing? And then it says at what height will she be at 2 p.m. So I'm just going to go ahead and interpret the time. So since we started at 1:13 p.m., and she's 52:11, I'm going to go ahead and change this into minutes. So 20 minutes later, I'm going to put it right here, 20 minutes later, she is at 56:51, okay? And then at 1:48, that's 35 minutes from the start. Okay, all I did was subtract 48 minus 13, and they're now 5,981. So that's what I'm going to use for my rate, okay? So I'm going to use this as my x1, y1, and my x2, y2. Okay, just because we can't put time, we can't put 133 and 144 in the formula. So we're going to go ahead and subtract our y values on top. So 5981 minus 5651. And on the bottom, we're going to subtract our x values. So 35 minus 20. Okay, I'm going to go ahead and put the top part in my calculator. So 5981 minus 5651. That is 330. And then 35 minus 20 is 15. Okay, I'm going to go ahead and reduce that. So 330 divided by 15, that gives me 22. Okay, or I'm going to put it as 22 over 1. Now remember the time. This is in minutes. And on the bottom, it is going to be the height. And it's at sea level. Okay, so it says, what is the rate at which she is climbing? 22. Oh, not minutes. I did it backwards. Whoops. Sorry, because the minutes was on bottom. Let me erase it. This is height, minute. So every minute, let me erase this. Audra climbs 22 feet. Oh, that does not look like a T. Okay, at what height will she be at 2 p.m.? So I'm going to go ahead and write this equation. So the equation is y equals mx plus b. We already know that the height is 22x plus, and the b is the starting height. Okay, so we are starting at 5211. So they want to know where will she be at 2 p.m., which is how many minutes later. That's from 1:13 to 2 p.m. 2 o'clock. That is actually let's see, let's do 60 minutes, because remember there's 60 minutes in an hour minus 13 is 47. That's 47 minutes later. So we're going to do y equals 22 times 47 plus 5211. So I'm going to go ahead and put that in my calculator. And that gives me 6,245 feet. So that's how high she's going to be off the ground. Okay. Number 4. It says in 2010, Little Elm had 3,646 residents. 5 years later, they had 1,750 residents. If the population grows at this rate, about how many residents will the town have in 2020? Okay, so let's go ahead and make a little table. So in 2010, that's 0 years later. Okay, that's at 0. There is at 3646. That's the start. Okay, then it says 5 years later. So 5 years later, it is 17,150. Okay, so it grew pretty quickly. Now in 2020, which would be 10 years later from the start. Okay, so 10, we are going to try to figure out what that number is. Okay, so this one wouldn't be too hard, because from 0 to 5 and 5 to 10, they're both equal apart, right? So if I find the distance from here to here, that should be that equal amount. Okay, so I'm going to go subtract 36. So 17,150 minus 3,646. That gives me 13,504. 504. So then that means that this difference should be the same thing. Okay, it should have the same rate of change. Because these numbers are the same, plus 5, plus 5, and then so should those ones. Okay, so I'm going to go ahead and add that number to the 17,150, and that gives me 3654. So this one would probably be the best estimate. And remember, it says about how many. Okay, so that's why we're estimating. The next one says, each change of 6 in the linear function f of x results from a change of negative 2 in x. What is the rate of change of f of x in relation to x? So that sounds kind of tricky, but it says, each change of 6 in the linear function f of x results from a change of negative 2 in x. Okay, so pretty much we have a table x, y. It says there's a change of negative 2 in x. So minus 2, we'll just say negative 2. Whatever that is, you subtract 2, negative 2, and so on. Then it says each change of 6 in the linear function of f of x. Whoops. So then that means that it's like that, plus 6, plus 6, plus 6. So then the change, a rise over a run, 6 over negative 2, that would give us negative 3. So that sounded super, super tricky, but it's not too bad. Okay, number 6. It says the function y equals 20x describes the relationship between the distance between 2 points on a map in inches. X and the actual distance between the points in miles y. What is the independent quantity represent? So just in case you don't remember, X and Y went to the doctor and they needed their ID. So our independent is going to be our X value. So let's see what it says here for X. The distance between 2 points on a map in inches, X. So what is the independent quantity? The distance between 2 points. Let me go ahead and highlight that. The distance between 2 points. And the actual distance between the points in miles. So then this one is going to be our y, which is our dependent variable. So the actual distance. So it says, what are the units of the rate of change in y with respect to x? So it's asking for the units. So it is going to be our y over x. Okay, remember this part is our slope, so that's our rate of change. So for every 20, it didn't give us a unit for, oh, it says points in miles. For every 20 miles is equivalent equivalent to 1 inch on the map. And that's it. Okay. Number 7, it says when the air conditioner inside a car is turned on, the temperature inside the car decreases at a constant rate. The table shows the temperature T in degrees Fahrenheit in m minutes after the air conditioner is turned on. What is the independent value? So the independent is always going to be our x value. Okay, so these are my independent. In this case, it says m minutes. So m minutes. Okay. The dependent variable is going to be the letter T, which they tell us here. T stands for temperature in degrees. Temperature. Okay, it says, what is the rate of change? So I'm going to show you guys how to find the rate of change on the table. Okay. If we see here, from 2 to 4, we add 2. From 4 to 8, it actually adds 4. And then from 8 to 10, it adds 2. Okay. And then from 80 to 75, it's subtracting 5. From 75 to 65, we subtracted 10. And from 65 to 60, we subtracted 5. Okay? Remember, it's our rise over run, so all you got to do is take -5 and divide it by 2. Okay? -5 divided by 2, that's going to be my slope. Now, we could have used this one right here. We could have used -10 and 4. Okay, the only thing with this one, -10 over 4, when we reduce this does reduce to -5 over 2. Exact same thing. And then this one's the exact same number. So it doesn't matter which one you use. You can use any of them. I think that's the easiest way to find slope, especially if you guys don't like the formula. Now, remember the trick that I showed you guys on the calculator? You can also use that trick to find the rate of change. I don't care how you guys find it, as long as you guys find it. So pick any method that you guys want. So the rate of change m is equal to -5 over 2. What does it represent? Okay, so remember the -5 here is from our temperature. So that means it drops 5 degrees. Okay, and then on this number, the number in the denominator, the 2 is our time in minutes. So every 2 minutes. Okay, so use the first point given. What is the equation in point slope form? So again, our point slope form is y minus y1 equals m times x minus x1. Okay, so since they want us to use the first point is 2 and 80. So our y is 80. So when we're subtracting our y1, 80. Sorry, my pen is running out of battery. And my m is 2. Okay, and then, my x1 is 2. And then my slope we said was -5 over 2. Okay, everything else stays the same in the formula. So y minus 80 equals m times x minus x1. Then it asks, what is the equation of the line? Well, to find the equation of the line, we do have to distribute this. And we get y minus 80 equals -5 over 2x. And then we multiply -5 times -2. That is going to give me a positive. And then 5 times 2 is 10. 10 divided by 2 is 5. Okay, then we add the 80. And that gives me, oh, my pen. I'm going to have to write with my finger. This cancels. Gives me y equals -5 over 2x. And then 5 plus 80 is 85. Then it asks, what is a y-intercept? So here is 85. What does a y-intercept represent? Remember, our y-intercept is our b. It's where we begin. Okay, so we are starting at 85 degrees is the start. Okay, which is the starting temperature of the car. Okay, but I'm not going to write all that. It says, what is the value of f of 16? So because it's saying f of 16, we're going to go ahead and plug this into our formula that we got. So it'll be y equals -5 over 2 times 16 plus 85. That's the equation of our line. I plugged it into this equation that we found. When I multiply that, that gives me -80 over 2, -40. How would it give me? 45, I think. Let me go ahead and plug it in just in case. So 5 times 16 divided by 2. Yeah, gives me 45. Whoops. Okay, this one's backwards. It says, what is the value of x when f of x equals 66.5? So instead of y, we put 66.5 equals -5 over 2x plus 85, and we solve for x. So I move over the 85 first. This cancels, so 66.5 minus 85 gives me negative 18.5. This is equal to negative 5 over 2x. And then we go ahead and multiply times the reciprocal. What I do to one side, I have to do to the other side. The 5's cancel, the 2's cancels, the 2 negatives make a positive. And then these two, when I multiply this times 2 over 5, gives me 7.4 is equal to x. Okay, the next one says the height of a candle f of x in inches is a linear function of the number of hours a candle has been burning, x. Each change of 4 in x results in a change of negative 5 in f of x. Okay, what is a rate of change? So here it says each change of 4 in x, remember it's rise over run, which your rise is your y values and your run is your x values. So the 4 should go on bottom, and then negative 5 should go on top. Negative 5.
I'm about to take my other one.
Okay, I'm recording. Sorry. It's okay. What did you do?
Mosquito bite.
Oh, I thought you smashed your hand or something. No, you're fine. Okay, and then it says, what does a rate of change represent? So it says here, the height of the candle, which is your f of x, in inches is a linear function of the number of hours the candle has burned. So that means that the negative 5 is my y value. So that means that it is shrinking, okay, because it's negative 5 inches every 4. And then it tells us it's hours. So 4 hours. And that's it for that one. Okay, just a few more problems. It's just 10 problems. Okay. The graph below models the changes in the temperature of a liquid during a laboratory experiment. Okay, so here's our graph. It says, what is an independent variable? So remember, independent, here we go again. X and Y went to the doctor and they needed their ID. Okay, so independent is my X value. Here's my X axis. That means my independent is minutes. And then my dependent variable here, if I look at my Y value, is temperature. So here I'm going to put temperature, and it's in F, which means Fahrenheit. Then we're going to find the slope, so we're going to count the rise over run. So here, whoops, I hate it when it does that. It's counting by 10, so 10, 20, 30, 40, 50, 60, 70, 80. And this way, 1, 2, 3, 4, 5, 6, 7. So it'll be 80 over 7. Now, we cannot reduce this. This is not going to reduce, so it's going to stay like that. What does the slope represent? Remember, 80 is our temperature, so, and it's actually negative. I almost missed that. So it drops 80 degrees every 7 minutes, because our y value is minutes. Using the x-intercept as a point, what is the equation in point slope form? So the x-intercept is 7, 0. So I'm going to copy down my formula. Y minus y1 equals m times x minus x1. And the point is 7, 0. Okay, so for my y value, it's 0. My slope is negative 80 over 7. And then we have x minus 7. And then this is y minus 0. So that's in point slope form. Now in slope intercept form, we simplify it. So y minus 0 is just y equals And then we go ahead and distribute the negative 80 over 7 to each one. So negative 80 over 7x. Now negative 80 times negative 7, two negatives make a positive, and that's going to give me a positive 80. When I put that in my calculator, 80 over 7 times 7. And that's it. It says, what is a y-intercept? The y-intercept is 80. What is a y-intercept? It's a starting temperature. Remember, your y-intercept is always a starting value. So starting at 80 degrees. Because remember, our y value is degrees. What is the value of f of 5? So pretty much they want us to take our function and plug in a 5 instead of x. And this gives us, I'm going to go ahead and put in my calculator, 80 times 5 divided by 7. This is going to give me 22.8. And it says explain what it means. So I ran out of space, but I'm going to explain it to you guys. That means that it's going to be 22.8 degrees outside in the car after 5 minutes. I believe it's in minutes, right? Yeah, it's in minutes. Okay. The next one says, what is the x value when f of x equals 0? So it's the same when my y value equals 0. What is my x value? So here, I'm going to look at our graph. Okay, our y value to be 0 is right here. Okay, so that means that my graph is 7. Okay, so that means that x equals 7, which means after 7 minutes, the temp is 0 degrees. That's all that means. Okay, and the last one, number 10. It says, the graph shows the cost for parking at a garage for different amounts of time. What is a y-intercept? Okay, so here we can see that it crosses a y-axis at 4. Okay, how can the y-intercept be interpreted? So if I look here, it's 4 and our y value is dollars, so $4. Okay, remember, it's always, our b is our starting value. That's where we begin. So we start, or the starting price is $4. It says, what is the slope? So let's see, from here to here, it is 4 units, from 4 to 8. And then from here, 1, 2. So it's going to be 4 over 2, which reduces to just 2. Okay? Interpret the slope. So to interpret the slope, it's 2 over 1. Remember, the y value is cost in dollars, and the bottom part is hours. So interpret the slope. The fee is $2 per hour. What is the equation of the line? So if we notice here, our y-intercept is 4. So it's going to be y equals, our rate of change is 2, so 2x plus 4. Okay, so pretty much when you go to this parking lot, you got to pay $4 up front. And then every hour, they're going to add an extra $2. Okay? It says, use the graph above. Which of the following is a true statement? It costs $6 to park in the garage. That is not true. There is a flat rate of $4 to park in the garage that is added to an hourly charge. Yes, that's most definitely true, but let's just check. The cost for 4 hours of parking, nope. The maximum charge for parking is $18. I'm pretty sure that is not true. Okay, and that's it.